Good afternoon, everyone. I want to thank you all for joining us for this session of our Practical AI for Marketers series. And today we are going to be speaking about the AI foundations. To start off, I'm going to introduce myself. I'm Jonathan Prantner, Chief Analytics Officer here at OneMagnify. And personally, I have been in the marketing analytics space for the past few decades, and I've been able to see firsthand how our relationship with data has changed in helping drive customer experience, especially in kind of the marketing and marketing analytics side of things. Um, OneMagnify as an organization has a unique approach, which is one of the things that drew me to the company, where they address things through a kind of analytics foundation, an intelligence layer, which really informs everything that they do. And then that is coupled with technological innovation as well as digital activation. And so, as we go through and talk a little bit about what AI really means for marketers, we'll see how that framework is something that we see replicated across all of the AI solutions. So, as we begin, the first thing for us to consider is what exactly do we mean when we say AI? AI is such a broad umbrella term that gets used in a number of different ways. And so, when we think about I want us to think about that the same way that we would think about science. Science can mean a baking soda volcano that an elementary school student builds, or it can mean a aircraft that's designed for space travel. Similarly with AI, it can mean a very simple system, or it can mean something which is very intricate and detailed. I like us to imagine the fact that most of us have grown up with AI in our households and never really thought about it. And the example that I use here is the thermostat. I don't mean a smart thermostat that we can control from our phones. I mean the standard on the wall thermostat. Crank the dial to 65 degrees. When it gets down to 63 degrees, the furnace will turn on. Once it gets up to 67 degrees, it will turn off. And what that is doing is the epitome of an AI system. It's taking information and data. In this case, it's taking the temperature in the household. It's using that to then make decisions. We have things set at 65, it's currently 63. Based on that, it's acting upon it, turning on the furnace, and then when it gets to a certain temperature, it turns off. So we have a system which utilizes data to make decisions and act on those decisions. So that is what an AI system does, but just as equally importantly, AI systems attempt to mimic a human process. So in the case for the thermostat, what that's mimicking is when I'm in the house and I'm cold and I would put another log on the fire to increase the temperature. Once things got a little warm, then I would open the flue so that some of that hot air can get out. That is what the thermostat is replicating in terms of a system, and it's doing that by taking data, making decisions, and then acting upon them. When we think about AI, though, we should also consider it, especially from the marketing perspective, of where it sits within the field of analytics overall. And so, if we look at the different branches of analytics, we have descriptive analytics, prescriptive analytics, predictive analytics, and artificial intelligence. Each of those serving their own function and usually working together in concert. So, descriptive analytics is something that helps us understand what has happened to date. So, it really helps us understand the past. This can be something that is relatively straightforward, where we bring together a table or a chart based on data that we have, or it can be something that's very complex, where we're using models to estimate contribution of what has happened in terms of historic sales. But the key aspect of descriptive analytics is that it's focused in on what has already happened. When we turn then to predictive analytics, now we're forecasting a future outcome. So this could be looking at a group of consumers, understanding their likelihood to purchase a new product from us, or consumers that are part of a subscription service, understanding which of those consumers are likely to cancel. Looking at our sales volume overall and forecasting out our revenue over the upcoming months. Predictive analytics is taking that lens and saying, okay, based on what has happened and what I know now, what do I expect either on an individual basis or in an aggregate basis? what do I expect those next outcomes to be? When we turn to prescriptive analytics, it's taking that concept of predictive analytics and moving it one step further to say, okay, based on what I know has happened and what I expect to happen, what should I do next to drive a certain activity? So if I have sales targets that I want to reach, what level of marketing should I put in place? If I want to reduce employee churn by a certain amount, what things can I do to retain those high value employees? And so it's taking that idea of the predictive analytics and going just one step further on it to say, based on what I know and what I expect to happen, how can I change that? What levers do I have to reach a desired goal? And then finally, that's where we get to artificial intelligence. And so AI is building on these different aspects to mimic that human decision making process and act based upon it. So that is the distinction between what we have with prescriptive analytics, which suggests actions, and artificial intelligence, which is going to act based on that data. So it's going to use what it knows has happened, what it expects to happen, what the optimal solution might be, and then deploy that. So that's where we get that distinction of AI within the overall branches of analytics. And when we look at how organizations use AI, it's really about fitting the AI solutions to your needs. And there are three ways that we see organizations are using AI to drive change. The first is at the individual productivity level. So this is where we have a lot of kind of AI powered and enabled solutions to help with a specific aspect. So this can be a software which will help to create a series of emails that we want to send out to consumers. This could be something like GitHub Copilot that will help our coders to actually develop the solution that they want to deploy and to be able to translate the concept that they have into actual code. The second group, which is where we see the most impact within organizations, and really the impetus of a lot of the internally developed solutions that companies are going for, are for process automation and improvement. So, this is taking a look at the way that we are currently interacting with consumers and attempting to use AI solutions to suggest optimal ways of doing that, deploy those optimal ways, and go forward. So, this is where we see the biggest changes taking places within organizations, and is really going to be where a lot of our focus on the discussion today is. Finally, there's this third category, which are these transformational solutions. And once we get into the specifics around different types of AI solutions, we'll see where these transformational solutions come into play. And this is essentially organizations that have a huge amount of data that they feel is very distinct from things that are going on elsewhere. And they want to actually build some of these AI models from the ground up, so training them from scratch. And as we get to the discussion of how we can use our own data within AI systems, we'll see why this is something that is very rarely used because of the lift that's required overall. So when we look at AI, there's a lot of different faces that we see in our everyday lives. And I myself group these into these three categories that I consider to be kind of the three revolutions that have taken place within AI. So the first is around machine learning and fuzzy logic. So this is a lot of the technology that drives the predictive analytics that we were speaking about before. It's really about quantifying aspects of a system into data and then using that data to drive decisions. The second area is around computer vision and speech recognition. So, this is really changing the definition of what we consider to be data. So, how we can use images and audio to understand what's going on, take those as inputs that then we can use in decision making systems. And then finally, the third area is natural language processing and generative AI. So, this is kind of the current revolution that we are a part of. And this is really changing the way that we interact with our consumers and our consumers interact with us. And the impetus around this is not so much understanding exactly what is happening, but really getting to that underlying why of things are occurring. It's providing us with context. It's providing us with the overarching themes that we have within things. And we'll spend quite a bit of time speaking about this specifically. But first, I want to start off by speaking about machine learning. So, machine learning has been around for a number of years. It's been an outgrowth of statistics, which was more probabilistic based, where we assume different distributions. It incorporated a lot of aspects from computer science to look at different techniques where we didn't have to make some of those assumptions going forward. But in its basis, machine learning is mimicking that human process of differentiation. So I want you to imagine for a moment that we are going to sort fruit. So we have apples, we have pears, we have lemons, we have tomatoes, we have bananas, and we want to put them into different buckets. And so, based on this, we're going to use different attributes that we can quantify about them. So, we can identify what shape they are. Are they oblong? Are they round? We can identify their color. Are they red, yellow, or green? We can look at their texture. We can look at the type of skin that they have. And based on these quantifiable attributes, we can say, this is most likely to be an apple. This is most likely to be a pear. And that is essentially that human process of differentiation is the heart of what machine learning is doing. So it is using these quantifiable attributes to do one of two things: to either sort things into groups. So is this customer going to purchase? Is this customer not going to purchase? Or to estimate a certain amount. Given that this customer is going to purchase, how much can we expect them to spend over the next 3 years? And so this is all driven off of the ability to recognize and quantify different attributes, use those to sort or estimate things. And it's using historic data to understand these patterns and to replicate that human decision making process. Machine learning has been around for a number of years, but within the past 10 to 15 years, there's really been a renaissance of it, and that has been driven by the XGBoost models, which are these gradient boosting models. And they took a slightly different approach to being able to estimate something, where they would say, okay, first we're going to build a model that gives us our best estimate. And then from there, in order to refine it, instead of building a number of sequential models as something like a random forest would do, it looks at how well that model fits, and then it focuses in on the errors. And then it builds a model to address those errors. So because of this, and because of some abilities that it has with simultaneous processing, it allowed a speed that we have not seen before in the ability to build, score models, and use those for data. So now these machine learning models sit at the center of a lot of things that are done in terms of estimation because of that speed of processing that those XGBoost algorithms have enabled. So now we want to turn to look at the way that sales and marketing organizations are really using machine learning and this form of AI to drive the customer experience. And so first off is understanding those propensities. So that can be looking at consumers and understanding their propensity to convert, to buy a certain product. So we're looking at all of these historic consumers. Based on those, we have these quantifiable attributes that we have around them. Similarly, if we were to look at the likelihood of a customer to churn, it would be the same information, but now we're looking at a negative outcome as opposed to a positive outcome for that. There's other types of models that we can do with this where we look at things like media optimization, where now we're looking at things at an aggregate level, understanding if we are driving certain level of media performance, what that will look like in terms of expected sales performance. We can use this to create forecasting. We can also use these not only to have the predictive type of understanding that we'll get from the propensity models, but using these for prescriptive models to understand, based on these activities, what are some of the next best actions that can occur. And I want to dive into a use case on this where we focus in on the specifics around a customer which had a large customer data platform. So for this customer, they were able to build out a number of these propensity models. So looking at a propensity to purchase a product, looking at the propensity for them to bring that product in for service or to sign a service contract, looking at the time to abandonment from when they're shopping to when they're no longer engaged. And what this organization did is they took all of this information that they had on that individual level, and they were able to generalize that into personas that they could then use to go out and purchase media. So when they were looking at those different personas, now they had the ability to say, okay, based on this type of customer, these are the audiences that we want to target. We want to be able to bring those in and then have expectations on what those customers are going to do. So, in order to understand what those customers are going to do, they took that information and brought it into a tactical and strategic media planner, which would allow them to say, okay, if I am going to spend a certain amount on this channel, I expect to get this sort of response. And that helped them segment those customers across the audience, segment their media according to that, use multi touch attribution to understand that if consumers have been exposed to A, B, and C, D, as opposed to those that were only exposed to A and B, what additional impact those other two media touch points had. That went into media mix modeling, where both the media mix modeling and multi touch attribution actually fall into that lane of descriptive statistics, very advanced descriptive statistics, but because they are explaining what had happened with media mix modeling, we then use those relationships to look at what we would expect to happen, and then we can use algorithms to optimize against those. So this is the example where machine learning really bridges across a lot of these and truly becomes an AI system when we allow it to automatically make recommendations and then act on those recommendations. If we turn to kind of the next revolution of AI, so this is something around computer vision. So, computer vision has been around since the 60s, and it has used a slightly more data intensive approach to modeling than what we saw from machine learning. It's using these neural networks where it's creating multiple different layers upon layers, where that allows it to estimate and create connections in order to drive an outcome. But when we think about any form of AI, we are trying to replicate a certain human process. So, for that process, for computer vision, it's replicating this process of perceptual mapping. So, imagine for a minute that we have a child that can speak, see, and hear, and you are attempting to teach this child language. So now we will show them a image of an orange and teach them that this is orange to try to create those neural pathways so that they have the relationship between what they are seeing and a certain piece of language. And so, with that process, as the child learns, they will make mistakes where they will see a basketball and refer to it as an orange. Once they get more information learning that that's not an orange, that that's a basketball, they'll have additional terms that they can use, additional abilities to differentiate. But what's important here is that we are not quantifying the aspects of this orange in the same way that we did with machine learning, where we said, this is round, it is actually the color orange, it has a texture of X, Y, and Z. Instead, we are relying on images. And those images are then able to be mapped so that once they are digitized and vectorized, we can see the underlying information around them. And then that is used to create things like object recognition, image segmentation, where we differentiate between types of images. But beyond that, it goes to things such as scene understanding, where we're able to understand when we think of something like the backup camera on a car, whether this is a shadow, this is a person walking, should this be in the image or should it not? And then it's also able to do pattern recognition and anomaly detection. We have someone on the team here who did a really interesting project where they were focused around satellite images and using those satellite images to look for changes to be able to identify natural disasters that were occurring. So from that, we're looking at an image, seeing the differences between the image, and allowing the models to identify if something different is going on there. So when we look at ways in which sales and marketing organizations are able to use computer vision, there are the excuse me, there are the forms of OCR where we're looking at optimal character recognition. So this is when we think about scanning documents, turning those documents, be them handwritten or typed, into text that we can have in a digital form. It can be used for proofreading, as we'll see in an example that we go through in a moment. We're able to look at layouts within stores to understand traffic flows around them, to understand as consumers move through a space, how having items grouped together or in different spaces enable additional purchasing from there. And then obviously helping consumers being able to envision what products would look like in their own environment through augmented reality for that product visualization piece. And so with this, I'm going to dive into an example around creative proofing. So there was a client that we worked with that had a large number of direct mail pieces going out. And not only did they have a large volume, but they had a huge variance in what those would look like. So they could have up to, say, 300 different layouts from that. And as anyone who has ever gone through a Word document and done, a find and replace, we know that it's very easy to make mistakes when we are going across a number of different creative proofs that we want to send out, where we may have a mismatch between a brand and an image, for instance. So what this client was doing at the time is it was going through a manual review where they would take a subset of those 300, look at them, approve that based on a certain random sample from that, feel that they were good going forward and pushing that out. But they were able to use computer vision and some algorithms and automation there to be able to take a look at those, to be able to break those images down into separate pieces and assure that those pieces align with one another. So ensuring that the text that they're getting from OCR, along with the images which they had classification models to do, that they would match. So if they were sending something out for, let's say, an automotive retailer, and they wanted to have Mazda, making sure that the image, the symbol, and the name all matched across those. So this allowed them to be able to proof every image to have a greater sense of understanding of what it was they were sending out. So now we're going to move to kind of that current revolution of AI and around generative AI specifically. And this is one that's extremely interesting to me, not only because it is kind of the revolution that we're living through, but because when we're thinking about that human process that it is mimicking, it is the one which is the least concrete. So generative AI is mimicking this process of sensory familiarity. And in order to explain sensory familiarity, I'm going to give an example. This past summer, I was on vacation with my family. As we were traveling around, we went into a number of different grocery stores. They were fine, but then one day I went into a grocery store and I knew this was the one for me, that it would have the products that I liked. It was not a Whole Foods, it was an independent retailer, but there was something about it that reminded me of a Whole Foods. So, what was that? Was it the scents? Was it the layout of the store, the lighting, the products that are featured when I first walked in, the sounds? All of those different sensory cues essentially are compared in my mind to the memories that I have, and then either related to positive or negative experiences. So in this case, the sensory familiarity was relating me to experiences where I was able to find what it was I was looking for. Generative AI is doing that same process. And it's doing this where it's using, instead of past experiences, it's using its training data and past knowledge. Instead of sensory cues as we walk in, it's using the keywords that we put into a prompt and it's matching them. And so it's building that familiarity and confidence based on how well it's matching that information. Once it's able to match that, then it retrieves the information that's associated with it, and we can reinforce these. So the real thing that happened here, there was a paper a number of years back, which is attention is all we need. And it was focused in on these transformer models. And these are really the things that have changed the way that we approach natural language processing. Because If we think about putting in a specific query, what we're doing, and let's say I asked a generative AI chatbot to create a 10-day itinerary for a trip to Jamaica. It's going to go through, vectorize that information. It knows that it's asking about a trip. It knows about a length of time. It knows that it's looking at Jamaica. As it goes through its past knowledge, based on the fact that I'm asking for an itinerary for a trip, it is more likely going to return information for me that are about the Caribbean island nation of Jamaica as opposed to Jamaica Queen. So it will be pulling that information together. But what separates these transformer models from some of the historic things that we've done in natural language processing is the ability to create longer connections within data to be able to understand the relationship between those. The example that I give here is for anyone that has ever gone online to excuse me there, anyone who's ever gone online to look for a recipe, we know that we're attempting to see what temperature we should set the oven at. And we have to read through an entire blog post first, talking about someone's trip or the first time they ever tried this food in order to get down to the recipe. Well, if we look at that blog post, it's a great example of explaining how these models are able to make connections that weren't available in past natural language processing models. Because historically, if I said, I went to the store on Sunday and it was closed, or on Sunday, I went to the store and it was closed, traditional natural language processing models can make those connections because it's seeing them close to each other in space. It may pull out the theme that says stores closed on Sunday and be able to isolate that. But if we think about this recipe type blog post where they say, oh, Sunday morning, I woke up and I went for a walk and then I went shopping and I did X, Y, and Z. And then finally I went to the store and it was closed. The traditional models will not be able to make that connection because the further they are in space, the less related that they feel they are. And that's what's known from the mathematical side as either an exploding or a vanishing gradient as it tried to make those connections. The transformer architecture was able to overcome that because of its ability to understand language and understand relationships. It's able to make the connections between the fact that this was a Sunday, retain that information as it goes through to when it was closed to be able to identify a possible connection there. And as we've all seen with these models, they are not perfect, but that's where the adaptation and learning can help reinforce what we are seeing across them. Probably for me, one of the most exciting things about this as a marketer is that the adoption of this generative AI technology is really being driven by both sales and marketing as well as product and service development. As opposed to if we look at the machine learning revolution or the computer vision revolution, those were driven in large part based on the engineering community. Here, because we are attempting to understand language, we're attempting to understand context, we're attempting to understand meaning, then we are able to identify the different aspects that we have across here as it relates to sales and marketing and that consumer experience. This is where we now get into going back to thinking about those three different levels of AI that we spoke about. So there's that individual productivity, which are tools that are helping us solve a specific solution, or we have those kind of total transformational models that organizations are building from the ground up. When we look at that kind of middle level there of being able to automate and improve different processes across the organization, one of the key things is the ability of using these models to take advantage of the data that you already have. So when I look at these large language models and the responses that they return, I always say that there's something which would make our middle school English teachers proud because they follow a very standard format of first this, second this, also this, in conclusion that. So they follow a very clear structure. And what we're able to do to help organizations is being able to use that framework to understand the questions and then use your own internal data to help answer those. And there's a few different ways that we can approach that. One is through what's known as retrieval augmented generation. So if we think about asking one of the publicly available generative AI models to explain customer service issues that they have had in our chain. What we're going to get back is something very generic, where it's going to tell us about different types of customer service problems that people may have, but they may not relate directly to our chain. They may not even relate directly to our industry. If we were to take that and then supplement that with something like, let's say, dealer reviews, excuse me, with like Google reviews of our franchise locations, we can use retrieval augmented generation to really take those reviews, vectorize them into a database. So now when we're able to prompt that chatbot and say, return this for my locations, on the back end, what it's doing is it's saying, given all of this information that I have here about reviews about my locations, answer this question. So it's taking it, it's using that model to understand what it's looking for, and then it's using the information that we have vectorized to return a response. If we want to take things a step further, because let's say the voice is not appropriate for what we're looking for, or we have a lot of specific nomenclature within our industry, that's where we can go to some of these lighter approaches to fine tuning. So if we look at parameter efficient fine tuning or low rank adaptation, what these are doing is instead of building one of those models from the ground up where we're attempting to make those connections, we are using those connections and fine tuning a piece of those. If we look at some of the publicly available models that are in market right now, let's say we look at the Meta model Llama V2. They have a number of different versions of that, but even the smallest version has 7 billion parameters that it's using. And when we go to fine tune a model, we don't want to degrade that because we don't want to lose the ability that it has based off of all the data that it was trained on to be able to find the answers and the solutions that we need. So that's where either the PERT approach or the LoRa approach allows us to take a subset of these and to tweak those parameters without degrading that entire underlying system. If we turn next to look at the way that sales and marketing organizations are using generative AI, the first area is the one that we are all probably most familiar with, and this is chatbot interactions and customer support. Because the great things about these models are that they're able to understand language better than our historic natural language processing abilities, and they're also able to generate responses that are more human sounding, being able to respond against customer feedback to then, as we think about them prompting that, taking the results of what they had before, sending that along so that they can get better and better answers. But in addition to that, there's some ways that this can be used more on the back end. So the first is around predictive analytics for lead generation. So understanding the different aspects that we have within a customer journey, understanding how we can predict the expected outcomes from that, using these models to look at some of those parameters and then make automated recommendations on that. If we think about, say, having a new product launch, and we want to generate some content, we would have our copywriters put something together that has the exact brand voice, the exact message we want to put forward, and then we can use that with the help of some of these large language models and generative AI to say, okay, based on this, maybe I'm going to also bring in what customers are searching for, what they're saying about my brand publicly. I'm going to use that to create a landing page that will help me with SEO optimization. Or I may take that same press release that I have, use a generative AI model to say, okay, I now want to create a email campaign of 5 different emails that I have to help build to that solution. And that allows us also to do the same thing for social media campaigns to be able to say, I have these samples of my voice for my brand in this platform. I want to take this and adjust it to that voice so I can have different sounding things there. I'm going to dive into one example here, which is around call center data. And I personally love call center data because it's so different from most of the things that we have when we analyze text, because every conversation is really a dance between the agent and the customer. And so we've created this measure that we utilize called emotional progression, because any individual utterance or kind of turn in the conversation, we can use traditional tools to look at the sentiment of that. But then we also look at that change of the sentiment over time to understand the ways that the agent is able to affect the trajectory of that conversation. And one thing that's just the truth about call center data across a large number of organizations is everyone knows it's important, so they save it. Usually ends up in a data lake, and based on that, there's not that much that's done with it, because at the end of this, you may have some customers that we survey. You may have an agent give a disposition to the call at the end, but there's just so much data there that it makes it very difficult to surface insights that are not happening as broadly. So, what we've done with this in taking this data is using these traditional natural language processing techniques of sentiment and emotional progression. And then we pull that forward into a standardized prompt. So then we have a prompt that goes forward and says, okay, I want you to take all of these conversations, summarize each one across 5 main points of that call, provide the theme, the sub theme, the sentiment, and the emotional progression for each of those, and then give me the outcomes for both the customer and the agent. So the example that we're looking at here is a customer who's looking for a full-size pickup truck with a heated steering wheel. Myself, I'm in Buffalo, New York. So if you know anything about Buffalo, it's that we have the Bills, we have wings, and we have snow. So understanding the need of having a heated steering wheel for a pickup truck in the type of weather we deal with is something that's very personal to me. So this customer was frustrated. They said, I spoke to the dealership. I couldn't find out why I can't get one. So now I'm talking to you. The agent isn't able to provide any additional information in that. We see then the customers getting more and more agitated. They're thinking about, well, I may have to go with a different manufacturer, do something different. At that point, the agent says, oh, well, actually, we have these sedans available that have heated steering wheels. So based on that, then, would you consider this? The customer at this point is, a little bit irate. They say, no, if you can't understand the difference between a full size pickup and a sedan, I don't even know why I'm having this conversation. And so then we can summarize that outcome. Now, if we were to use traditional natural language techniques, we may see there was something with heated steering wheel. We may say there was something about a lost sale, but we wouldn't be able to really summarize this information unless we had someone go through and review everything. Now we can go through, because if I'm running the customer service department, maybe I want my agents suggesting these other vehicles, even if they're not an exact match, or maybe I don't. But now it's raising that possibility to me and letting me dive into it and take a look at things. So when we think about how AI fits into any organization, we're going to address this from kind of 3 different lenses. We go through what's known as an AI readiness process with organizations. And so we're going to focus on 3 different areas, one of which is data, one of which is kind of infrastructure, and then one of which is our goals. So we'll start with the data. So when we look at using information to create AI systems, we start with a kind of simple exploratory data analysis to get the data that we're looking at, figure out those kind of one-to-one relationships that we can have within the data. Once we're able to do that, we can start building out models. So if we think about the things that we spoke about in terms of machine learning, scoring models, forecasting models, we can do that and we can produce those. That takes us to our next level, where then we put those into a pipeline. We're able to have those run continuously over time. We start to compare against different modeling approaches so that we can get the best fit from that. And then once we get to that advanced level where we're really going to make decisions and actions based off of the AI, that's where we move into a production deployment, where we're going to start looking at the machine learning operations to understand if the data I'm seeing now looks like the data I've seen before, or if there's any shifts in that data that makes things move. It allows us to kind of fine tune some of that data there. But then the next piece we look at is understanding where you are in terms of your AI journey, not only in terms of that data quality and integration that we looked at in the last step, but also data privacy and compliance. What does it mean for you to use this data? And if we're thinking about using some of these different systems, particularly everyone's dealing with this with the large language models and generative AI. Do I need my data to be self contained and have a system running on my own servers? Am I able to use an API where I move that data out? Where does PII and other concerns come into that? When I'm looking at building out my team, what is the skill set needed and what is the training that I need to have in order to create these models, run them, and then equally important is what is the infrastructure and technology stack? Because as we mentioned, with some of those models, the smallest ones having 7 billion parameters, they take a lot of memory and a lot of computational power in order to run. So what does that look like? And what are the costs that I can expect if I want to run this model and have it available across my organization? The final piece is really a little more of that strategic of what are we trying to solve. So what is it we want to do with AI? I've had a number of calls with organizations where they're looking to do AI because they know it's valuable and they want to do something new. But do we have a specific goal, a specific problem that we're trying to solve, either from our internal processes or from the way that we relate to our customer? Based on that, what data would help us support that? How can we bring that together and integrate it? Then we go through that process where we can set that up, look at the different forms of AI and what's most appropriate to solve this individual problem. Um, I want to save a few minutes for questions here. So I just want to let everyone know, thinking about this, if you have questions about this, about where your organization is with AI, any of the specifics I spoke of, or anything else that you would like to hear, you can definitely reach out to us at ai@onemagnify.com. Just send us an email. Our AI for Marketers series is going to continue. Next month, we'll be talking about a marketer's guide to data science collaboration. So, understanding a little bit of that kind of AI and data science readiness journey and how to work with either internal or external data science groups. We're going to have a couple of presentations coming up, one based on enhanced sentiment, which is kind of a really unique thing because when we talked about that customer care data or anything else we have a small subset of consumers that are surveyed, even smaller subset that answer the kind of open-ended questions from there, but they may say this was excellent service or horrible service. What does that really tell us? So we're going to talk a little bit about how we can use that information to go back to the transcripts to understand why it was exceptional or awful service. And then we're also going to be talking next month about augmented intelligence and how having in the human in the loop helps extend the AI process and the life cycle of those models. We're also going to have an upcoming Forrester report around generative AI and what it means for B2B marketing that we will be sending your way as well. So before I wrapped up and turn things over to questions here, I did want to talk a little bit about what's coming next. So talking about excuse me, those different revolutions that we had, the machine learning revolution, which was really driven forward by the XGBoost models, the computer vision and what was pushed forward with the neural networks there, then those transformer models that we have now. When we're looking at those transformer models, they're great at really creating that view of conversation. But for anyone that has played around with some of the image creation, things are a little bit hit and miss. But there was a paper that came out a couple of years ago now, which is the concept that an image is worth 16 by 16 words. So it's about taking images, being able to separate them into different batches, using those to then quantify that information and use them in the transformer architecture for image recognition, segmentation, things of that nature. But the reason these models are still a little bit hit and miss is because we have models with these new LLMs that are extremely good at understanding language. We have other models that are very good at certain aspects of images, but the connection between those is a little difficult. That's why when we try these images, we may get something that comes out well, we may get something that is just a little bit off. But the next revolution is in these multimodal models. So not only are they utilizing these different models and bringing them together? They are training them across inputs that are text, that are audio, that are video, that are images. So from that, we have these new models that are coming out, which are going to revolutionize the way that we are able to create images and video and things of that nature. So I want to thank you all for your time, and then we can open things up for a couple of questions if we have some there. Okay, so the first question we have is what type of tools or platforms should marketing teams invest in? And so that depends a little bit on which of those three categories. So, from the productivity side, individual productivity, it's really about what you are helping to solve there. So, you really want to tie that into the specific aspect. If you're looking to use something that makes working with your HubSpot data easier, you're going to look for tools that integrate with HubSpot. If we're looking at something that's doing more of that overall process automation and innovation that we have there, the best thing I can say is that you need to start by thinking about where your data is, because with any type of data science model, AI model, the biggest cost in terms of effort, in terms of processing times, in terms of actual financial cost for that is movement of the data. So if you have something that is, set and your organization is working within GCP, probably using something like Vertex AI would be the area that you would want to go. If you have an Azure stack, then you're going to want to look for something that OpenAI has that will interact with that well. It's really about understanding your tech stack and then figuring out the best tool that will work seamlessly and associated with that. How can my team prepare for AI and increase their AI readiness? So there's a couple of different aspects for that. The first is looking at, once again, that technology stack to understand what you have and where tools can fit in. It's then about looking at that process to see what are the main things that you want to address. Because the best thing that we recommend to organizations is that we don't want to do AI for the sake of doing AI. We do AI when it's the right solution to solve a problem. So it's about looking for that, identifying those problems. And then from there, the actual deployment of these things, if you have a data science team, usually can use an extension of that. Where a lot of the training comes into this is the thinking about the data, how you will do that prompt engineering, what you want that system to look like. So whenever we do an AI solution, um, we are also able to identify the information that we have across that, use a solution architecture approach to start building that out. So the next answer is, are you recording this webinar and can you share it with members of the team? Yes, we'll be sharing it with everyone here shortly. So I want to be cognizant of everyone's time here today. If you have additional questions that you did not raise or that come to you later, please reach out to us and let us know. Once again, you can reach us at ai@onemagnify.com. And this is a topic that I really love discussing, so happy to carry on this conversation in the future. Thank you all so much for your time and have a great day.